All right, 13.1, use trigonometry with right triangles. All right, so the first one's just say to evaluate the 6 trig functions of the angle theta. So you are given a triangle.
I wish my paper did that.
Just like adjusted.
Apple's gonna make a notebook with like paper that adjusts your lines.
Please.
Like
That would be kind of nice.
It
It would make it a lot easier to grade things.
It looks like a cursive. Oh yeah, because our handwriting is fantastic.
Yeah. Basically, in case you don't know how to draw theta, it's a circle with a line through the middle of it.
Oh.
I just usually do it as one,
I
like...
thought it was curved. Mine be looking like cursive O's.
Yeah, same.
I do mine as, like, one motion, so I'll just,
Oh,
like,
so, okay.
draw it all the way through.
Okay,
usually.
well now I know it's supposed to be a straight
Now,
line.
yeah.
Well, I mean, what else is it gonna be? An O.
All right, and then we're given 8 and 3. So, from geometry, how would I go about finding the other side?
Pythagorean.
A squared plus B squared equals C squared.
Oh.
Yep.
That makes sense.
So then, plug stuff in. 8 squared plus 3 squared equals C squared. So 64 plus 9 equals C squared. What is that, 73? C squared. And then, obviously, okay, remember last chapter that we did, we had, you know, if you had something like this, you take the square root as plus or minus. Obviously, can't have a minus, like, length, a negative length, so it's only the positive one. So it's just going to be the square root of 73 is equal to C. Huh?
I don't think you can.
So what I'm going to tell you is don't worry about reducing it,
Oh.
even if it can.
What if it's a perfect square?
Oh, yes. Okay, if it's a perfect square, then yes.
Okay, okay.
But if it's like, let's say it was like the square root of 8, well, I don't care if you reduce it, but, because that's an easy one, it would just be 2 root 2. So it's fine if you want to reduce that, but if not, I'm okay with you also leaving it as the square root of 8.
Oh.
So typically on my keys, I'll write both, like, options, because half of the people will do it one way and half will do it the other way. But, I mean, if it's something easy like that, then yeah, you may want to do it, because it may also cancel something on the bottom. But otherwise, don't worry about it. All right, so we're looking for, I always set these up, same order. This is the order I want you to do them in. Sine, cosine, tangent, cosecant, secant, cotangent, keep losing things. Okay, the reason I want you to do it this way is it'll help you remember. Sine goes with cosecant, I can't talk. Cosine goes with secant, and tangent goes with cotangent. Okay, so sine of theta is what? I think y'all should know at least sine, cosine, and tangent from geometry.
Opposite over hypotenuse.
Okay, so that would be 3 over the square root of 73.
Oh.
Now, rules still apply from chapter 4. You cannot leave a radical on the bottom. So, all we do is, I'm going to actually show this step on this one, but ordinarily you don't need to show this. Okay, you're just multiplying by the square root of 73 over the square root of 73, which is going to give you on top 3 root 73 over 73.
I tried to forget everything from geometry.
Then I
Honestly.
realized, oh, maybe I shouldn't.
Didn't realize that
Oh, yeah. It'll be with you for the rest of your math career, unless you take stats. That's the only way you're not going to have trig anymore, if you go that route instead.
Take both.
All right.
Yeah, I think everybody's on like 3 now.
Cosine is what?
It is.
Adjacent over hypotenuse.
Adjacent over hypotenuse. That's going to be, yep, 8 over the square root of 73. Okay, again, I'm still multiplying by this. The square root of 73 over the square root of 73. I just, for the sake of space, I'm not going to write it. If you don't write it, I'm going to assume you just know what you're doing. You don't have to write it.
Okay.
Just
8.
8 square root of 73 over 73. What is tangent?
Opposite over adjacent.
So that is
8 over 3. Wait.
3 over 8.
8 over 8.
Opposite of the
What of the angle. I don't know.
So now I'm going to show you, now that you have these, your other 3 are ridiculously easy.
Okay.
All you do for cosecant is take sine, you have originally, and flip it over. Square root of 73 over 3.
You do? Oh, that's someone else.
You just like flip all of them.
Yep. Cosine, flip it, square root of 73
There better be no catch, too.
over 8. Tangent, flip it over. Or sorry, cotangent, flip tangent over 8 over 3. It is really that easy. Okay, now, for some reason, this always happens, there's always one, okay, that decides that when they do cosecant, that they want to start with sine being 3 root 73 over 73, and they want to flip that, and then they've got to go through and do all the extra work of getting the radical off the bottom, canceling things out, blah, blah, blah. Use what you start with, and it makes your life easier. Now, if you had, let's say that the sign initially was flipped and was the square root of 73 over 3, okay? Obviously, when you go to flip it, you're going to have to do this process that we did over here. Like, if these two were flipped, like, in the actual problem, okay, you would still have to do something with these to get the radical out of the bottom. But if there's a radical in the bottom of sine, cosine, or tangent, when you flip them, it's going to be on the top. You don't have to worry about it.
Are we done
With that problem, yeah. So this,
For now.
For now.
this is your final answer. Okay.
I want my paper to do that.
Okay, so when I'm looking at your test, your homework, whatever, I'm looking for them to be in that order. Okay, makes it a whole lot easier to grade. Makes it easier if we need to go over them. Okay, and it makes it easier for you. I'm trying to help you by lining things up. So, sine, cosine, tangent, cosecant, secant, cotangent. Okay. if you think you can do the rest of it by yourself, sure.
No, I couldn't do them.
Will any of these have fractions other than those actual answers?
No.
Like the lengths of the like the sides of the triangle.
Yeah.
No, not likely.
Okay, good.
But,
'Cause I might
well,
do myself.
I'm not going to say you do get your calculator, but I'm also not going to say that you entirely don't get your calculator. For some of this, you will have it. Some of it, you won't. Like your unit circle quiz, no calculators.
What's a unit circle?
A spawn of the devil.
I heard about it because
Oh, is that the one where we have to like memorize?
complaining about it last year,
Yeah,
and I was sad.
I think I know it.
It worried me like every year.
We do it in 13 point, oh, we actually start it tomorrow. Or not tomorrow. We're not actually doing 13.2 until Wednesday.
Oh.
We're not going to get through all this today.
So we're gonna do this for like 2 days.
Yeah. There's more to this than this. Like, we'll probably do all the examples today, and then tomorrow will be your work day on it,
Okay.
basically.
Fun.
All right, so this one, theta is over here. 8 is here, and then this is 2 root 17. So I need to find the other side. First and foremost. So, somebody tell me how to set it up.
A squared.
Yeah. A
What?
squared plus
What'd you say?
A squared plus 8 squared.
Oh, I thought he said m squared. I was like, where did m come from?
A as A or B.
Yeah, it doesn't matter. I'll mix them up all the time. Technically, I think the shortest side's supposed to be A, but like,
Oh.
nobody really cares.
Okay.
As long as your hypotenuse is C, it doesn't really matter.
Cool.
So that. Oh, okay.
Okay, so it goes to both.
Yeah.
Yeah, it's the whole thing being
17,
squared.
17.
So the squared goes on the 2, making that 4, and then making the square root just go away here. So that on that side is 4 times 17, which we'll figure that out in a second. Then a squared plus 64. What is 4 times 17? 68. Alright, so then a squared is equal to 4. A is equal to the square root of 4 or 2. I'm still in the mode of writing plus or minus, so I was about to write plus or minus still. Like, no, never mind.
Okay, so the square
Don't do
doesn't
it.
go to the. It only goes to the thing on the outside of the radical. You don't square the 17.
No, so the radical is a square root, so you're taking the square root and you're squaring the square root. So the square root and the square cancel each other.
Yeah. Okay.
Alright, so then a is 2. Alright, so then, bless you.
Thank you.
Sine of theta, cosine theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta. Alright, so what is sine of theta?
2 over 2 square root of 17, and then we have to like get that square root.
Yeah, so first of all, when you have something like 2 over 2 root 17, those 2's can cancel each other and go away. So those are gone, and then now you just need to multiply, since you have a radical on the bottom, by the square root of 17 over the square root of 17, leaving you with the square root of 17 over 17.
Now can those
Cosine is what?
8 over 2 square root of 17. Can you like cancel 2 square root of 8?
Yeah, so you can do 2 is gone, making that 8 of 4. And then what?
4 square root of 17 over
4 square root 17 over 17. Tangent,
2 over 8.
which is
1 over
1 over 4. Okay. So then cosecant,
2 square root of 17 over 2, which
reduced to square root of 17.
yep. Secant,
2 over the square root of 17 over 8. Then it should be square root of 17 over 4. And then 8 over 2 over 4.
yeah. And if you've already done like the reducing for tangent to make it 4 over 1, you can just go ahead and say that cotangent is 4 without writing the whole thing. But if you want to, like, that's still completely fine. I'm just letting you know. I don't care if you skip that step. Let's see. What problem do I need to do next? 10. All right. So those ones, they gave you a triangle. Good to go. Cool. Next ones don't give you the triangle. It says let theta be an acute angle of the right triangle. Find the values of the other 5 trig functions of theta. Okay, I still want you to write your answers like this with all 6 written in it, mainly because you're given the one and the whole reason is so that you can just know to flip it to do the other one. Okay. So 10, we've got cosine of theta is equal to 5 over 8. Okay, so what I always do when I get a problem like this is I always go ahead and set up my answer section. I'll show you, don't worry.
Well, you know that measure
But we don't have a sign.
that's adjacent, and then the hypotenuse is 8. So then you have to do Pythagorean Theorem to find the other one.
Yeah, so I go ahead and copy over the thing that I know so I see what I'm trying to find still. Okay, and then what I'm going to do is I'm going to come over and I'm going to draw my triangle. I tend to always draw my triangles the same direction if I can, so just makes it easier. Always going to make this angle theta for me personally.
Does it matter which angle you make?
No, as long as it's not, you know, your 90-degree one.
90 degree one.
Which mine doesn't look very 90-degree, but it's okay.
Mine doesn't.
All right, so you said that cosine is adjacent over hypotenuse, meaning that the 5 goes here, and your hypotenuse is 8. So I just need to find the other side. And I'll show you too, like, another thing. Obviously, we always say that the Pythagorean theorem is a squared plus b squared is equal to c squared. But if you're ever, like, not given one of the sides, okay, that's not the hypotenuse, you can always just go ahead and just remember that it would be c squared minus, like, b squared. And then that way when you start actually writing the problem, you don't have to, like, go through and, like, do everything. You know what I mean? Like, it'll kind of save you a step of writing, so, like, that's fine. So, plugging in numbers, I've got a squared is equal to, let's see, 8 squared minus 5 squared. And a lot of times I'll go ahead and, like, under this step, I'll go ahead and, like, list it off as, like, the square root of, I try to save as much writing as possible when it comes to this. So 64 minus 25, which, what is that? Is that 39?
Yes.
So a is the square root of 39. I don't think that could be reduced even if you wanted to, because then that'd be 3 and 13, I think. So that wouldn't work. So then I just need to figure out sine. I already had cosine, find tangent, and then the other ones will come from there. So what would sine of theta be?
3 and 13.
Huh?
Square root of 39 over 8.
And then tangent.
Square root 39 over 5. And then cosecant be 8 over square root of 39. And because the square root of 5, so we go 8 square root 39 over 39. Secant would be 8 over 5. Cotangent, that's just, you know, it's 5 over square root of 39. And you know the drill, and then 5 square root
I
of
do know the drill.
39
I've done it for a long time.
over 39.
Yeah. If you want to, if you can, like, get to the point where you can see, like, that, whoa, when you flip this is going to automatically give you this. I don't even care if you write this part once you get used to it. Like, if you don't write the 5 over the square root of 39 equals 5 root 39 over 39, if you go straight from the, you know, tangent and flipping it to 5 root 39 over 39, that's okay. If you feel like you can skip that and do it, if that makes sense. All right. 12. So 12 is the cosecant of theta is equal to 10 over 7. So set it up. Applebee's?
No.
I like this movie.
Please tell me y'all have seen the commercial. The Applebee's commercial. Okay.
Which one?
The one with the song that he just started.
I don't remember what he's. I didn't remember.
I said fancy like, and she said Applebee's.
That for some reason they think is a country song.
Yeah, it's not.
Definitely not.
It's not.
But they play it on country radio anyways. Like,
Fancy like Applebee's.
it's catchy, don't get me wrong.
It really is.
It is really catchy.
Yeah.
But it's not.
I can't. It's just overplayed.
It's a fact.
Cut it. Okay, let's draw the triangle.
Alright, so again, I would first fill in cosecant. Now, because you're probably less familiar with where things with cosecant go, you may want to go ahead and do sine because we have cosecant, so we can work backwards to get sine, which is
7 over 10.
7 over 10. Okay,
I mean,
yes.
Yes.
Okay, so then opposite
Hypotenuse.
over hypotenuse, so that's going to be 7, 10, and then I can find the last side, so a squared is equal to 10 squared minus 7 squared. You'll notice I progressively start writing less and less letters as I go because it's just... Eventually I'll get to the point where I just write a equals the square root of 10 squared minus 7 squared because it's just... It's a formula, so...
So could you like do 10 squared minus 7 squared equals 3 squared?
What?
What are you saying?
Is there I mean, you
Well,
could-
would that be a true statement?
No.
It wouldn't.
Okay, so then no, you cannot.
That's not what I did, but I was just wondering.
So a equals the square root of 100 minus 49. What is that, 51?
It can reduce, but I don't feel like doing it, so.
Isn't it 3 and 17?
I don't know. 3 and
You
something.
said it could reduce, so I was
Oh yeah, that's
asking.
pretty, no, that's a
3 and
no.
something. So
I
maybe
think it's
it
3
can.
and 17.
I don't know.
Oh man.
Alright, so now I've already taken care of sine and cosecant, so what is cosine? What? Can you repeat that?
Square root of 51 over 10.
Yes.
That's what I meant.
He's like, blah, 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 blah.
You so mean.
It's okay. That's me by the end of the day. The other day I was trying to teach factoring to Algebra 1, and I was like, blah, blah, blah. I was like, you know what? Just work on some
Do
problems.
it. And then tangent would be 7 over square root 51. And then you know the drill, so.
What?
I know the drill, but do you know the drill?
Yeah, that's the question.
Like I said, you know the drill. I mean, I hope everybody knows by now.
I'm just mad I can only fill like 3 problems.
I know, isn't it so
Oh,
annoying?
Yeah, I've done.
I only
Each
put 2.
page I've only done 2.
This is not it.
That's just not it.
Alright, so what would secant be?
10 square root 51 over 51.
Beautiful. We're moving past
None of
writing
this
it
is
every time.
beautiful. No, none of this is beautiful.
No, I said that because we're moving past writing it every time.
Oh, yes. That's beautiful.
Okay, so then cotangent.
Square root of 57 over. I mean, what the?
Square root
Square root of 51 over 7.
I mean, I get where you can like, yeah. I
Yeah.
got you.
Yeah.
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 Like, yeah.
Yeah.
Oh yeah.
Yeah.
What one are we doing next?
Like,
9.
It's hard because I don't have my stuff written on like the papers anymore. It's all because this is where I converted last year, so I'm like seeing which problems I need to do to make sure that like I cover everything that is important.
She did and then she went
All right, do y'all need to see any more of this particular type, or are we okay with this one? We're good with setting it up.
Do you watch it
Okay.
Southern?
It's kind of funny.
All right,
That's the one where, like,
now we're gonna have some fun.
No.
That's
Your
not.
definition of fun is very different from ours.
Yeah.
But I love math.
How much space?
Well,
do
we
have
don't.
for
the
this
issue.
problem?
That's the
How much
issue.
space do you need for the fun problem?
Full page.
Like you need to be able to draw two triangles.
No.
I draw small
No.
lines.
And then 1, 2, 3, 4. 4 lines, but some of them have like, if you like to write your fractions on 2 separate lines, then double that.
No,
Yeah,
I'm
just gonna
canceling.
start a new hand.
I'm canceling Trig. I'm canceling it.
Trig just got
You're
canceled on Twitter.
All right, so the problem that you are given says find the exact values of x and y. So,
Is this an equilateral?
no, it's still a right triangle.
Why do you draw
Whoa.
it like that?
Because that's how it's drawn in the book.
I don't like
It looks too ill.
It looks too ew.
Okay, I'm going to write everything that's given in black, and then I'll switch to another color for the other stuff.
I had to look at it like that.
Okay.
I was like, what?
Okay, you are more than welcome to do this if you want and flip it.
I want
It is a
Okay, if you want to see it.
I'm confused.
Just flip the whole paper. There we go.
That worked.
Beautiful.
Or flip your book. Ah! Flip your book and then, you know, write it down or copy it down the direction that it goes. But anyways, okay, and then this is the square root of 21. This is y, and this is x.
So this is oh, so that's the hypotenuse.
Wait, I did this wrong.
That's fine.
Now I'm going to ask if you remember anything about a
No.
triangle that looks like this from geometry.
I mean,
Remember
I
something,
do.
but it was in my
Like
memory.
45.
I remember we did
Is it
something with
45,
it,
40,
but no.
45, 45.
It's
How many degrees are inside of a triangle?
180.
180.
Wait, oh.
Okay. Okay.
I mean, I'm not
So-
wrong.
We also thus know that this is 45 degrees.
I'm not wrong.
Okay, the square represents 90 degrees. Okay, now I'm going to draw this.
Square root of 2 and then 1 and 1. They're around there somewhere.
Okay, I'm going to draw another triangle over here that we can compare to. Okay, so you said square root of 2 and 1 and 1. Where does that go?
The square root of 2 is the hypotenuse. And then the
Oh,
1
do you
is
remember
wherever
that
else.
formula? Man.
It was in the video.
So this is a 45, 45, 90 triangle, which produces 1, 1, root 2.
Okay. What now?
Oh, that.
Oh yeah, it wasn't.
So now
It wasn't.
the sine of 45 degrees is what we're looking at. Okay, I'm going to use this one and I'm going to use this one. Okay, so that way I'm looking at the same angle for both. And we're going to do a comparison. So the sine of this angle, okay, the one on the left, is what?
45 acute.
Like
Y
in terms of opposite over hypotenuse, what is it?
over square root 21.
Okay. And then Peyton, the other one.
1 square root of 2.
All right, so now that we have this, just ignore that. Okay, that was just showing you what we were looking at, okay? Now, do you remember, I don't know if Miss Holloway would have taught you this way.
Miss Holloway.
Be the pretzel. Have you heard that before?
Oh,
Yes.
yeah.
The pretzel.
Yes.
Yeah.
we
All
know
right,
the pretzel.
we're going to cross multiply.
Ways of the pretzel.
Be the pretzel.
I love the
Oh.
pretzel.
So, I'm going to have, over on the left side, the square root of 2 times y, or y root 2, equals, on the other side, 1 times the square root of 21, or just the square root of 21. I'm going to divide by the square root of 2, so y is equal to the square root of 21 over the square root of 2. But I can't leave it that way. What do I need to do to it?
Multiply square root of 2 by both
Square root of 2.
top and
Square root of
bottom.
2 over square root of 2, which gives you what?
Square root of 42 over 2.
Okay, so that's equal to y, but because it's a 45, 45, 90 triangle, that also is what x is equal to.
Oh, no way.
So x equals the square root of 42 over 2, and y equals the square root of 42 over 2.
They won't all be this easy. Which is sad.
Wait, so do we have to find like the code
No.
tangent?
No.
No, this one we're just solving for x and y.
Oh.
No.
Thankfully.
I don't think that's
All right, I'm going to do 19 because it's another type of triangle.
I gotta tear my paper upside down now.
Oh, you.
It's
Go
gone.
by.
It didn't look like a right triangle, so I felt the need to fix it.
Mine.
It's a 30, 60, 90.
Yo.
All right, so you're given this is 30, this is 12, this is y, this is x.
X.
Okay, y'all just established that this is 60.
Don't look like 60 on my paper.
Doesn't look like 60 on mine either. It's okay.
Imagination is what we call it.
All right, so my new triangle. Oh dear, that's not gonna look like a right triangle.
Our new rectangle in triangle.
Our new rectangle.
Oh dear. Well, it looks kind of like it.
I
Just
just,
go
I
with
just
it.
Well,
flipped it. I just
My
flipped
triangles
it.
look very
What do you
different.
think we have? Our paper doesn't change it for us,
These look
okay?
very different.
Our
I
problems are
flipped
worse.
it.
It's okay. If you actually saw the ones last year before I knew that I could do that, my triangles look like they're like.
Oh,
That's how they
what
look.
mine look like.
look at my right angle.
All right, so comparatively, okay, I've got a 30, a 60, a 90 that doesn't look 90, but that's okay.
Mine.
So, what is the special type for 30, 60, 90?
Oh,
Let me look.
oh.
Two and
Oh,
the
what?
square root of-
2 is the hypotenuse,
Yeah.
and then square root of 3 and 1.
Yeah.
Where does the square root of 3 and where does the 1 go?
Does it
Wherever.
It does matter.
Ew.
Smallest
square root of
side
3
goes with smallest angle.
Square root of 3
But my
goes
triangle
on
sides
the
look the
adjacent
same and then-
end of 30, and the 1 goes opposite.
So 1 is bigger than the square root of 3.
No,
No,
Maybe.
I don't know.
it's not. But
Wait, no.
So that means
one is
60,
adjacent-
you would agree that 60 degrees is bigger than 30 degrees, correct?
Yeah.
Okay, so the bigger side goes with the bigger angle. So the square root of 3 and then 1.
that's what I said.
So one is adjacent.
That
I
was
said
not
the
what you
square root- I
said.
said the square root of 3
No,
is
Josh,
adjacent
you
to
didn't
the
say that.
30 angle, and 1 is the opposite of the 30 angle.
Also, you can just
That's
look at the
basically what
sides
that
and
is.
just tell that side's longer.
I just
It
said
depends
more,
on how people draw.
I said it more complex. I saw the picture in my head,
No, Josh, you said it wrong.
but
Okay.
Josh,
Josh,
admit when you were wrong.
I wasn't wrong.
All right, so
Is that the long
Josh,
nose?
it's okay.
I'm going to first of all start out with the 30-degree one and find
What are we talking
Sir.
we're going to find x first.
Okay.
Okay.
Wait. Hold on. Yeah, cosine. Yes, we're finding y first.
Okay.
I can talk today. It's fine. All right, so we're going to use the cosine of 30. Okay, obviously we're not actually taking the cosine of 30, but that's going to give us, okay, adjacent 12 over hypotenuse, so 12 over y is equal to, on the other one of 30, square root of 3 over 2. Be the pretzel.
What?
Be the
All right, so then that gives us 2 times 12 is 24 is equal to y square root of 3. So I'm going to move my y to the left just because Y is equal to 24 over the square root of 3, which gives me 24 root 3 over 3.
And then can we reduce? Wait, 3 doesn't.
Yeah, you can.
Yeah.
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 No.
Yeah.
Because it's being
Yeah.
So it equals
multiplied.
8 square root of 3.
Okay, so Y is now 8 square root of 3.
Bams. Math.
It has been math.
All right, but
But
We have to find X.
we haven't found X yet.
Oh my.
So now
The angles aren't the same. Why was
the other one was
They
the
were the
same because
same
they were
thing.
both 45 degrees. All right, so sine of 30, okay, is going to be x over y, which is x over 8 square root of 3. On the other one, opposite over hypotenuse is 1 over 2. B, the pretzel.
Eat the pretzel. I wanna eat.
So 2x is equal to 8 square root of 3.
Bingo,
Divide by 2. X is equal to 4 square root of 3.
easy.
that's what that's.
So x was 8 square root of, or sorry, y was 8 square root of 3. X is 4 square root of 3.
Wait, so could you use, I know we use the 30 degrees, but like could you use the 60 degrees?
Yeah, you could have.
So you could just pick.
I typically, not so much with these, but when we get to, I think it's like 13.5 and 13.6, I'm going to typically tell you if you have the option to use known values, use them. Like in this case, it didn't really make a difference.
Like a less chance.
Yeah, it's less chance of, because then if you solved something and then you use that solved value, but the solved value is wrong, it's going to throw off everything else. Now, I'm not like going to penalize you and give you no points if you used that number for the rest of the problem. If you did the process right, you just had the wrong number. Like, I'm not like mean or anything. Let's see. I'm debating.
We have 3 minutes.
Trace
We
Minotos?
should just not.
Yeah, we'll save the last 3 for tomorrow, and then you'll have the rest of the time to work on. The next one's basically you're given angles and sides, and you have to find all the missing pieces.
I have no energy.
But you'll need your calculators for it because it's not all going to be whole numbers that are nice and pretty. So.
Oh.